Welcome to vblog 49. This is business math. Business 135, fun with math and Excel. Hey, we're in Chapter 9. We love Chapter 9 because we love calculating future value. Put some money in the bank and see how much it's worth when you plan on withdrawing it. Hey, we're in Sheet Tab FV for Future Value 2. Here's our example. We're trying to find the future value, or maturity value, or compounded amount, all synonyms. And we're going to invest $2,000, principal, present value. The annual rate we've been promised is 10%, and the number of compounding periods per year, 2 years. We're planning on leaving it there for 10 years. This is exciting. We get to put in 2,000, leave it there for 10 years, and see what it's worth in 10 years. First, let's calculate total number of compounding periods, right? Because we have 2 periods per year that they pay us interest, and 10 years, so that's probably 20. Equals 2 times 10.
20.
Then we want to calculate our period interest rate, because if they're paying us for a half of a year, we would love to use the 10% for the half year, but that's not what they're going to use. They're going to use 10 divided by the number of compounding periods. So, equals the interest rate divided by the number of compounding periods. There we go. They're going to give us pay us interest 20 times over this 10-year period, and each period they're going to pay us a period rate of 0.05 or 5%. And they'll keep adding it, the interest into the account, keep adding it, and we will be earning interest on interest. Hey, here's our calculation here. Equals the present value, or principal, times, in parentheses, 1 plus, and we'll go ahead and use our period rate. Notice we've already done the division. There's the little I divided by n. Close parentheses. Ooh, and there's our caret. By the way, caret is shift 6. I should have said that in the last vlog. Shift 6. And there's our caret. And then we want total number of compounding periods. So it's raised to the total number of compounding periods. Enter. And we're not going to round that because we're not using any subsequent calculations. That is cool. $5,306.60. Look at that. From $2,000 to $5,306.60. If you subtracted this from this, that'd be a total interest of $3,306.60. Hey, let's do it using our Excel future value function. You ready? Equals FV. The rate, don't get tricked. If you forget what these mean, remember, go up to insert function. We're going to just use this screen tip for here. I'm going to click on the period rate, comma, NPER. Again, if you forget what that is, click right there, but we know it's total number of periods, comma. There is no payment. We're not paying in each half year any amount, so we're going to skip that by typing another comma. Notice that's really cool. If I backspace and get back to this comma, see how the PMT is bold? As soon as I type a comma, it gets rid of the bold there and moves on to, present value. That present value is how much it's worth on the day we put it into the account. And we're going to use a minus here because that $2,000 is coming out of our wallet. And then close parentheses. Wow, same answer. So there it is. I love compound interest. $2,000, 10 years later, $5,306.60. Hey, let's do another example. Actually, let's go to FV4, and then we'll go back to FV3. We're going to read this one here. Maria Carlota deposit $4,300 in the savings accounts, paying 3.5 annual interest, compounded daily. Sounds like your typical savings account. But she deposited it on July 9th. And withdrew the money on August 17th. So she didn't leave it in for a full year, not for a full period. Well, we're going to have to calculate the fraction of a year, right? Instead of 1 for the number of years, it'll have to be some fraction of a year. Find the value of her investment, money deposited on August 17th. So she puts this in on July 9th and withdraws it on August 17th. We want to find how much interest did she earn. Oh, I shouldn't have all this filled out. I hope you don't. If you do, click in cell B9 and hit the delete key. then click in. We're going to delete all of these. Those are the variables that we have right here. There's the principal or the amount that we put in the present value. There's the annual rate promise. Ooh, number of compounding periods, 365. And we want to put our date, July 9th. That's the day we put it in and the day we took it out. Now, let's scroll over just a little bit here. We can actually look at a little picture here. If I right-click that cell and say Show Hide Comment, it'll show it. Same thing, but written by hand. The trick here is you gotta find the number of days between July 9th and 17th, which we will do in Excel in a moment. But when you do that, you get 39 days. Then X, which is years, is, oh, that's 39. That's supposed to be 39 right there. I did the calculation right. I just wrote the wrong number there, late at night or something. 39 divided by 365 equals that right there, and that's the part of 1 year. So now we can plug into our formula. If we're doing it by hand, we just plug in the numbers. There's the principal, or present value, times 1 plus, and there's our annual rate, 0.035 divided by 365 is raised to the, how many compounding periods per year? 365. How many years? That's how many years. When we do that, and actually we could have skipped the chase and just realized that it's 39 because we're compounding daily, and if it's in there for 39 days, then the number of total number of compounding periods is 39. So when you do all the calculations, we get down here, $4,316.11. So the interest we earned was $16.11. All right, let's see how to do this in Excel. And the beauty here is that we will not have to take out our calendar and count on our fingers and all that, because we know how to calculate the number of days between two dates. You ready? Equals the later date minus the earlier date. And as we remember from a couple of chapters before we've done this, when we Control Enter, that formula sucks the format, so we're going to use our keyboard shortcut to get back to general number format. Control Shift tilde. If you forgot how to do that or don't like keyboard shortcuts, then just go to Format Cells on the Number tab and select General. 39 days. Now we can figure out the years because we have typed in 365 there. That's the number of days in 1 year. Equals the 39 divided by 365. Now, total number of compounding periods. We're going to do this even though it's kind of silly. We're going to take the total number of compounding periods, 365, times the number of years, a part of a year, 39. Notice if we rounded that, then we'd get something different there, so we kept it unrounded. Now, the period interest rate, we're going to say equals the 3.5% divided by 365. That's going to be a small number. It's 0.00009. That's very small. But that's the amount, that's the interest rate, daily interest rate. All right, now let's do our future values and our future value function. Equals FV. And then what's our rate? Remember, that's period rate. So I'm going to click on that. Comma. NPER. That's number of compounding periods, 39. Comma, I do not have a regular payment. It's just a lump sum we put in at the beginning. Actually, in Chapter 10, we'll get to use that. Comma, to skip it, and watch the bold. It moves to present value, and we know that present value, when Maria Carlota deposited this $4,300, it was coming out of her wallet, so we're going to put minus, and click on that $4,300, close parentheses. You can see the formula up here, too. Enter. $4,316.11. Now, the original present value, or principal she invested, is this amount right here. So, the interest earned, and I just remembered, hey, we're going to use this in a subsequent calculation, so we have to click back up here, and we did not round. So we're going to actually edit this right up here. We're going to come up, and right before the F, but after the equal sign, we're going to type the word round. And then open parentheses. That's cool. That means we can just round this whole big thing there. That number is just that future value, because the future value function spits out a number. So we come to the end, comma, and 2, since we're going to the penny, close parentheses. And then enter. There we are, $4,316.11. Let's come down here and do our calculation for interest equals the future value, maturity value, minus the original principal or present value. There it is. There's our interest. Let's go ahead and click on our future value 3 and do another problem here. And then we're going to come back to that Maria Carlota one. That's a good one. All right, the situation here is, we're going to put $5,000 in the account, and we've been promised an annual rate of 2%. But it's compounded 365 days, and the years are 4. So our goal is to find out how much we have in our account at the end of 4 years. So let's calculate total number of periods equals 365 periods per year times the number of years, 4. Enter. The period interest rate is equals 2% divided by 365. That's a small number. 0.000054, and continuing on. Now we can do our formula. Our math formula equals the principal times, in parentheses, 1 plus the period rate, close parentheses. Caret is shift 6, and click on the, 1,460. That's how many periods there are for this investment. Imagine doing that by hand. If you were not using this lovely little formula here, or the future value formula, you'd have to do each one of those days and it'd be terrible. That's a lot of periods to calculate interest for. All right, now let's do our future value function here and figure out what our $5,000 will be worth in 4 years. Equals FV, open parentheses. Click on the period rate, comma. Click on the NPER, which is total number of compounding periods, comma, minus the present value. Remember, we've got to put that extra comma in there because we're skipping an argument. And then close parentheses and control enter. There it is. So it looks like we are going to get $416.42 interest. And that's only on 2%. So that's pretty good. All right, let's click on future value 5. Here's a Maria Carlota problem. Here, let's read this. This is the same one as before. And so we're going to skip over that one. But we are going to use this one here. Maria Carlota deposits $4,300 in a savings account, paying 3.5%. Hey, so far it sounds the same. Annual interest rate compounded daily on July 9th. But here's what she did different than the time before when we did this. Maria deposits an additional $690 into the account on July 31st. She withdrew the money on August 17th. Find the value of her investment on August 17th. And how much interest did she earn? Now the trick here is, see, on July 9th she put in $4,300. But then she put a separate amount in on July 31st. So we have to do 2 separate calculations. This $4,300 sits in there for the whole 39 days, because we already did this one. And then this $690 sits in there for, well, we have to figure out how many days. Let's do the first part, and this is the same problem as before, so I'm just going to do the future value, and we're going to round it because we're going to use this in a subsequent calculation. Equals round, open parentheses, FV, because that's a function, and then rate, period rate, comma, the total number of periods, 39 days, comma, and the present value is minus the 4,300. I'm going to close parentheses. And notice the nice thing about Excel is it'll give you a color code. So there's a green parenthesis there and a green parenthesis there. That means we're finished with the future value. But there's still one more black parenthesis right there. And so now look at the screen tip. It moved. It knows that that's the number, that whole future value thing. And so now we have to do comma 2 for digits to the penny we're going to round. Enter. That is for the first amount only, $4,300. Now, we got to do the second problem and then figure out what the total interest is. Principal or present value is 690. That's 3.5%, 365 days. But here's when she deposited it, July 31st, and here's when she withdrew it. Darn, I have these numbers there too. I'm going to delete those. I'm going to delete all those. Now, I'm going to come to the number of days. We've done this lots of times, but practice makes perfect. Equals the later date minus the earlier date. Control Enter, and then Control Shift tilde. 17 days. Years is equals $17 days, that's the part of the whole, divided by the 365, that's the whole or the base. Enter. Ooh. So that's 0.0465, etc. of 1 year. That's the number of years. All right, now we calculate our total number of compounding periods, N, number of compounding periods, times our years. Boy, that's silly. That was a silly way to get 17 because we already had it there, and we know it's compounded daily, and that's the number of compounding periods. Wow. All right, now we do a future value. Equals future value, open parentheses. The rate, I'm going to click Escape because we didn't calculate the rate. Let's click here in cell B45, and the rate is going to be the 3.5% divided by the 365. Enter. Wow. And now we can do a future value. Equals future value, open parentheses. The period rate, comma, NPER, which is the total number of compounding periods, 17 days, comma, comma, minus the present value, and that's the 690. So 691 and 13 cents, only $1.13. Now the present value for, we're actually going to do this together because our goal is to calculate the total amount of interest for this savings account. So we're actually going to add both of the principles together here, the present values, equals the 4,300 plus the 690. Enter. And this right there is not right. That should say future value. Future value equals. Now, here's the trick. We have this amount and this amount. We did it in 2 steps, so now we just add them together, and that's how much is in the account. I'm going to Alt equals, and then click on that 691 and 13 cents. Hold Control, and click on this 4,316 and 11 cents. Enter. Now we can calculate our total interest for the savings account, the future value minus the present value or principal, and there we have it, 1724. All right, let's do our next future value calculation. Future value. We're going to invest $20,000, an annual rate of 6%. We have number of compounding periods, daily, and for 2 years. I've already calculated here the total number of periods, 365 times 2, and the period interest rate. Same here. I'm going to come down here and just use our function. We're going to calculate how much we will have after 2 years investing $20,000 at 6% compounded daily. Equals FV, open parentheses. The rate is the, wow, that's pretty small there, period rate, comma, NPER is 730 days, comma, comma, minus the 20,000, close parentheses, enter. There it is, 22,549. So if we wanted to calculate the total interest, equals, we're going to say equals this amount, the future value, maturity value, minus our initial investment. $2,549. That's wonderful. Just put it in. Let's let the money sit in the account for 2 years, and at the end of 2 years, you get $2,549. All right, when we come back in our next vlog, we'll talk about present value. Present value is this whole process in reverse. We know a future value, so if you wanted to have $22,549.71 in exactly 2 years, the question is, how much would you have to put in the bank account? That's $20,000, and that will be our calculations for our next vlog.